The first couple sections of Chapter 5 is a bunch of terms, and I think it's terms that you've largely seen before. But if you don't know the names for things, it's just going to get real confusing. So my plan is we'll do 2 sections of the book. I have a review assignment, and we'll do a quiz on sections 1 and 2. And then I think we have like 4 and 5 together grouped up. I found people do a lot better if I break it into smaller chunks before the quizzes. So that's kind of the plan. Grades went up a lot when I started doing that. So first thing, we have a line. A line, when we're talking about it in math class or in a geometry type class, is it's straight. Ooh, that's not supposed to happen. It is straight, and it should go forever. So I'm going to write goes forever. But when we're drawing a line, we're going to assume that the line is always straight and that it keeps going, going, going. So if you wanted to do an example, you could say, you know, within the limits of my ability to draw straight, that's supposed to be a line. I have a little bit of a hook there on the left side. A ray, you could kind of look at it as though it's half of a line. That's not really a fair thing, because how could you have half of something that goes on for forever? It's like dividing infinity by 2. But by that, it would kind of be like if you would take this line up here and like hack it off right there. One side of that is going to be a ray. So a ray is going to have an end point, but then go forever in one direction. So a ray is going to be something like that. That's what I mean by half of a line. So for that, then, it's going to go forever. So goes forever in one direction. So it goes forever, but it only goes in one direction. The other end has an end point. We okay for lines and rays?
Yep. Yes, sir.
Cool.
Yes,
A segment, then, is going to be, it's going to be a part of a line between 2 points. So part of a line between 2 points. So part of a line between 2 points. And if you wanted to, you could do, you don't need to put the dots on the end, but I'm going to put like an end point, a dot, another end point. It'll also be straight. If you wanted to, you could label those like G and H. Often they go alphabetically. And then that's going to be the line GH, they call it. So maybe I should have tried labeling all of these things. If we had this line up here, could maybe call this EF. And the abbreviation that they write for that is an E and an F, then they put a little arrow above it, or a line going both directions. So EF, something like that.
And then BH.
For the ray, anybody have a couple letters for the ray? BH. So if we take for the ray, we have to put one at the end. And now the symbol for that is going to be a BH, and the arrow only goes to the right. It's kind of trying to show it starts at the B, hits the H, and keeps going.
Right.
I get the BH. It's initials. So, and then for the GH, oops, so GH would just be the letters GH with just a bar over the top. Something like that. You okay on those? Cool. So 2 or more lines, rays, or segments. So 2 or more lines, or a line and a ray, or a segment and a line, meet at a vertex. So the point where these things cross or connect are going to be called a vertex and form an angle. So I'm going to try to draw something down below. I'd encourage you to try to copy it as best as you can. But I'm going to start with just a line that goes on forever, kind of going up and to the right. And I'm going to put a point E kind of in the bottom part of that line. And starting at E, I'm going to make a ray that goes kind of down and to the right. So it starts at E and then keeps going to down and right. And I'm going to put a point F on that ray. So that'll be my ray EF. And on that first line, I'm going to put another point up near the top, and I'll just call that a D. And connect D and F with a segment. So. And it's okay if your angles and stuff look a little different than mine. Really, the point that I'm trying to get at is this, that we'll refer to this here as a vertex. And technically, we have several vertices. It's like plural for vertex. Wherever these things meet, so like right there is going to be another vertex, right there is another vertex. But I'm just going to ignore those two for now. And I want to talk about that angle. This angle right here, how do we call that angle? So that's going to be my angle.
Right angle.
It's not a right angle because a right angle has to be how many degrees?
Acute?
It is a acute angle, isn't it? I look at that and think, man, that's a cute angle.
What is that?
Okay, so ways that we could label that angle, though. One, we could call it angle E. So they'll do like a little angle sign, something like that, and then a capital E. Because it's at point E is the vertex, they'll call it angle E. Now that gets a little bit deceiving because is it that thing that we put in there? Or is this bigger thing here angle E? Or maybe even this like 180 degree thing? So angle E is not always the most clear. Or the little angle sign. Anybody think of 3 letters that'll tell us that little black angle we have there on the inside? Can't do EDF. The order matters. What letter has to be in the middle if we're talking this little angle thing right there? So we want to say this part here. Fair enough? So we could say DEF, where that vertex is always going to be in the middle. So angle DEF. I'm going to make them all capitals because deaf. Sometimes I wish I was deaf so I wouldn't hear you guys talking quite so much in class. But okay, I digress. Angle, instead of DEF, it could also be getting close to lunchtime.
FED.
FED. Should have went a different way with my joke. Yeah, all the talking has me kind of fed up. But I'll be here all week. Okay, you guys okay for angles?
Yeah.
Awesome. Types of angles. You guys were calling my angle an acute angle, and that is true because the angle...
Smaller than 20.
Perfect.
Degrees.
So less than 90 degrees. So less than 90 degrees. So if you have something that's less than 90, not equal to, it has to be less than 90, less than a right angle, then it'll be an acute angle. A right angle has to be how many degrees?
70 degrees.
Actually, I'm going to back up a little bit. I'm going to do like the little picture's worth 1,000 words. So I'd encourage you to draw something that's less than 90, maybe something like that. A right angle, Dorian is right. Maybe other people said it too, is 90 degrees. So I'm going to try to draw something. I'm going to have a vertical line straight up and down. And then a horizontal. So that there's going to be a right angle. Anyone remember what they put in that corner in the vertex? Nice. They kind of turn it into a square. They'll put like a little symbol like that to show that it's a right angle.
But isn't that
Well, this one here is going to be a right angle because it should be 90. This is acute. Yep. And obtuse angle. An obtuse angle is greater than 90 degrees. So then I'd go and try to draw something that's going to be larger than 90 degrees, maybe something like that. So greater than 90 degrees, something like that. Have you guys ever learned straight angles?
Is it just straight across?
Yep.
I learned it in Africa.
So if you have a straight angle, it's going to be 180 degrees. Or it's really just kind of like a straight line. And you could put a dot in the middle if you want to for the vertex. But a straight angle is really just a straight line, which kind of for me is like, why? You know, what's the point? But it comes up more like when you do geometry in high school and you're trying to do proofs, that you might get like straight angles showing up in your proofs. That a straight angle has to be 180 degrees. So. Now the next thing, you'll notice at the top of your next page you have supplementary angles. Bottom of this page we have complementary angles. Those are going to be two terms that people mess up a lot. The way that I keep them, well, one of them is going to be how many degrees, one of them is going to be how many degrees?
One's going to be 90 degrees.
One's 90 and the other is?
108.
180. Nice. So I'm going to write supplementary here. I wouldn't if I were you. dot, dot, dot. I would not. Alphabetically, what comes first, C or us? S.
C.
Do you agree C comes before S? Complementary alphabetically comes before supplementary? What comes first, 90 or 180?
90.
90. So complementary is going to be the 90-degree one. Supplementary is going to be the 180-degree one. So let's write out complementary then. It's two angles, so two angles, whose sum is 90 degrees. I'm going to move up a little bit and then try to draw a picture. So if you wanted to, you might want to start with just make a nice right angle. It doesn't have to be vertical and horizontal, but I find that's probably easiest for me to draw. But you agree that right there is 90 degrees or close to it? So we want to have two angles that add up to 90. So basically just put another ray somewhere in there. You know, you could make yours like mine if you wanted to. And if you wanted to, you could even try to eyeball it and say, well, this one here maybe looks like it's, I don't know, 70 degrees. So then the other angle for mine has to be 20 degrees. You know, yours might not be 70 and 20, but it should be two numbers of degrees that together add up to 90, because sum means you're adding them. Ready to turn the page?
Yep.
So supplementary angles is going to be two angles whose sum is 180 degrees. And if you want to draw this one, I would just start with a straight angle, and by that really it's just a line. And then add another ray in there somewhere. And you could eyeball it if you wanted to. I think that looks like about 60 degrees. So my other one will be 120. But you could pick different angle measures if your picture looks different. Maybe mine's a little more than 60. You could put one right down the middle and do 90 and 90 if you wanted to. If you want to, you could add the how to remember. That's what I was talking about before. So complementary are 90 degrees. Supplementary are 180 degrees. It's alphabetical. Kind of killed my B in there, but alphabetical. It's alphabetical. C comes before S, 90 comes before 180. So, yes? Cool. Congruent angles. Congruent is just a fancy math word for, equal or the same. So two of the same numbers are equal. And by that you could say like 4 equals 4. You know, for numbers we just say equal. If you're talking angles, they say two of the same angles are congruent. And the symbol is going to be similar to an equals, but they put a tilde. If you remember that word from Spanish class, above the equals. So maybe they'll do something like angle B is congruent, so it equals with a little tilde above it, to angle ABC. And I suppose if we wanted to, you could draw the picture and say like, so if I have two rays, something like this, put that B in the middle, an A and a C.
Wait, what is that squiggly line above?
So this thing here, this whole thing together means congruent. So if you're talking about angles that are being equal, technically its angles are congruent. And here's the sign. So angle B, this angle right here, Dorian, is equal to angle ABC. You know, so that'd be, I'm sorry, I should say angle B is congruent to ABC. Good.
Yes, sir.
Dissect in science class means you cut up something. Bisect means you cut it into halves, into two equal parts. So bisect, cut in half. So if you're going to have an angle bisector, it's going to be a ray that cuts an angle into two.
Equal parts.
But instead of equal, we use the
Congruent.
yep,
Squiggly line.
two congruent. It's easy to say equals. That's what we've always been doing, but technically it should be two congruent angles.
But why do you have to say two congruents?
Because in math, the word for equal angles is congruent angles. So And if you want to give drawing that a stab, you could say, well, I have this here. And then I sometimes do best if I try to put a dot in the middle. That looks like it's about halfway. So something to aim for. You should try to use congruent.
But will you mark us off?
I don't know. I'll be tempted.
On a test, maybe.
So if we want to label all this thing up, you could put some dots on there. Now I'm going to put a M, a N at the vertex in the corner, and then an O, and I'll put a P. So you could say, if you wanted to, just to get used to the notation, the ray NP. So in other words, this middle part here, this middle thing. What do I put above the letters N and P if I'm trying to represent that thing? Like that?
Go this way.
Yep, we need to have the arrowhead on it because it's a ray. Has a starts at N, goes through P, and keeps going. So NP is the angular bisector of angle. What's my angle that we just bisected? What three letters am I going to put in there? Nice. MNO. If angle MNP is congruent. So what we're trying to say is we're saying this ray, NP, is the angular bisector of MNO if angle MNP, if this top angle, is congruent to anyone?
ONP.
ONP, nice. Angle ONP.
Yeah.
Angle ONP. You could also say PNO if you wanted to. You could say PNO or ONP.